All right, so yesterday we introduced standard form of ellipses. X squared over a squared, y squared over b squared equals 1. It has to equal 1. That's the key. What was the secondary equation that helped us find the foci? That was c squared will equal a squared minus b squared. And remember, there's nothing in the standard form that means like the a doesn't have to be under the x. The b doesn't have to be under the y. When in all reality, a needs to be the bigger of the two numbers. Okay? As long as you remember the number under the x tells us how far to go in the x direction, and the number under the y goes in the y direction, so up and down. That's all that really matters as far as that's concerned. And then you have to remember the bigger number has to be first here. Make sense? All right, so let's try a few examples. So let's say we have something like x squared over 36 plus y squared over 9 equals 1. How far right and left are we going to go? 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Easy enough. How far up and down? 3. So 1, 2, 3, 1, 2, 3. And we can draw our ellipse. Okay. Two of the things we have to label are our vertices and our co-vertices. I like calling them coverts. Where are you going to find your vertices? Well, the vertices are not always the top and bottom. They're not always the right and left. It's the bigger number. So which way did we go further? We went right and left further. So those two are the 6's are going to be our vertices. So I would label them as positive and negative 6, 0. Our co-vertices would be the other two. Okay, they're still vertices. Can you remember what is a vertice? Like a parabola has a vertex. What is, if I said what's the definition of a vertex, what is a vertex?
Like furthest point?
Yeah, you can think of it as like a maximum or a minimum, like how far up, how far down. You can also think of it as like a change of direction point, where like I'm going down, 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 down until I get to this point, then I start going back up, right? So all 4 of these points are vertices. But we just want to be able to distinguish between, there's a difference between these 2 vertices and these 2 vertices. Does that make sense? So like this is still a vertex, but it's a smaller vertex. So we call that one, we call those the co-vertexes. So those we would label as 0, positive and negative 3. Are we good so far? Okay, then we got to find our foci. So we use our c squared equals a squared minus b squared equation. The only thing you have to remember is it has to be the 36 minus 9, not 9 minus 36. 36 minus 9 is 27. So c is going to equal the square root of 27, which, yes, would simplify to 3 root 3. What direction would we go 3 root 3 now? Remember, the vertices will always be on your major axis. And in this case, which axis is our major axis? The x-axis is our major axis because we went further in that direction. So square root of 27, that's like 5.2, something like that, a little bit bigger than 5. So I'd go 1, 2, 3, 4, 5, a little bit right there, and right about there. And then we have to label those. So our foci, that's the plural word for focuses. Focuses just sounds weird. So Yeah, octopi. So the foci are at the points positive and negative 3 root 3, 0. And that's it. So my question to you, what would be the difference between this equation, so x squared over 36, y squared over 9, what would change if I just change and I put x squared over 9 and y squared over 36? Same numbers, but what would change as far as my graph? The only thing that would change is instead of going right and left 6, I'd go right and left 3, right? Up and down 1, 2, 3, 4, 5, 6. So that would change, right? Kind of missed. What would change as far as my labeling? Would the vertices still be the 6s or would they be the 3s? There'd still be the 6s. The only difference is it'd be 0 plus and minus 6, because now those points are up and down instead of right and left. My co-vertices would still be the 3s, but now it would be plus and minus 3, 0 instead of 0, 3, right? The c-squared equation is still going to be 36 minus 9, right? Which is still 27, so it's still going to be 3 root 3, right? But what would be the only difference? They'd be on the y-axis now instead of the x-axis. So my foci would now be at 0 plus and minus 3 root 3. So all the numbers would end up being exactly the same. And that makes sense because it's really the exact same ellipse, isn't it? Like it's the exact same size ellipse. So all the numbers should be basically the same. The only difference is really direction now. So instead of going right and left is the major axis, now we're switching axes. Does that make sense? Easy enough? Okay, one quick question. Is a circle an ellipse? Is an ellipse a circle? One of those two statements is true. Which is it? Ellipse is not a circle. This is not a circle.
It's like a square is a rectangle, but a rectangle is not a square.
Right. Now, let's say I gave you the equation x squared plus y squared equals 25. What is that? Circle is a radius of 5, right? How far right and left are you going to go? 5. How far up and down are you going to go? 5, right? Let's say we thought it was an ellipse. Can I put that in standard form as an ellipse? Yeah, I could just divide by 25. Because this number has to be a 1, right? So I'd get x squared over 25. Hate it when it does that. Y squared over 25. How far up and down am I going to go? 5. 1, 2, 3, 4, 5. Up and down 5. Right and left 5, right? And then I would draw my ellipse, which looks a whole lot like a circle. What if I tried to find my focal points? I would do c squared equals a squared minus b squared. What am I going to get? 0. I'm going to get 25 minus 25, which is 0. How far up and down am I going to go? Right and left. Where are my two focus points? Right at the center, right? It still works. It's just weird because it's actually a circle, it's not an ellipse. So what ends up happening is the more elongated it gets, like this ellipse that we did is fairly elongated. Where did the focal points end up being? They ended up being really close to the outside, didn't they? As this becomes more and more circular, meaning I go right and left closer distances, right? So let's say I went x squared over 16 plus y squared over 9, right? I'm only going to go right and left 4, and then up and down 3. It's definitely not a perfect circle, but it's more circular than the last ellipse I did, right? When I do my c squared equals 16 minus 9, I get 7. C is going to equal the square root of 7. Square root of 7 is like 2.4, something like that. What happened to my focal points? They're starting to work closer and closer and closer to the center point. The more circular you get, the closer those ellipses will be together, or those focal points will be together. The more elongated it gets, the more those focal points get tucked in right next to the vertices. Make sense? All right, everybody take a look at page 600 and, where do I want you? 637. 637. I'm going to pass out some graph paper. People online, I did post some graph paper you guys can print out. I highly recommend graphing these with graph paper because it just makes your life a little easier. And by the way, if you guys are ever at home, if you just Google graph paper, there's so much printable graph paper that you can find for free, super easy. All right, so let's try number 3. We're all going to graph number 3 together. What's number 3 say? Actually, no, we're going to do number 4 because that's the first problem of your homework. So let's do number 4. What's number 4 say? X squared over 4 plus y squared equals 25, right? What's the first thing anytime you do a graphing problem you have to make sure? Is it in standard form? Is this in standard form right now? No, which means I have to get it in standard form. This 25 can't be here. This has to be a 1. Well, how do you turn a 25 into a 1 and don't say subtract 24? Divide. So you're going to divide by 25, which means you're going to divide this by 25, which means you also have to divide this by 25, which means I end up with 1. I'll put it back in red. 1 is going to equal, this one's easy, y squared over 25. What does this turn into? X squared over 4, and if I divide 1/4 by 25, I get over 100. This is the standard form of that. Which means, how far right and left am I going to go? Right 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up and down. 5. And you draw your ellipse. So, you can label 2 of the 3 things we need right now. Where are my vertices? My vertices would be, are they the 10s or the 5s? They're the 10s, so that's 10, 0, and negative 10, 0. So positive and negative 10, 0. My co-vertices would be the 5s, right? So that's 0, 5, and 0, negative 5. So 0 plus and minus 5. Then I got to find my foci. So I would do c squared equals 100 minus 25, which is 75. So c is going to equal the square root of that. 75 is 25 times 3, so that'd be what, 5 root 3? Which way am I going to go 5 root 3? Up and down or right and left? Right and left, because 10 is bigger than 5. Square root of 75, just to put it on the graph, well, let's see, 64 would be 8, 81 would be 9, so not quite 9, 8 point something. So 1, 2, 3, 4, 5, 6, 7, 8.6, and that's all you really need to plot in there. But then more important, label it, would be my foci would be at positive and negative 5 root 3, comma 0. Easy? Questions so far? Okay, I told you, every single homework assignment you do, there's two types of problems. Question ones are, here's an equation, you put it in standard form, graph it, label all the parts. What's the second type of problem you got to do? Here are the parts, your job, write the equation. So everybody look at number 17. What do they give you? So they give you a vertex, and I don't know why the book does this. They give you a vertex at 5, 0. Well, if there's one at 5, 0, there's also one at negative 5, 0. They just didn't list them both. And then they also tell us there's a co-vertex where? 0, negative 3? Which means there's also one at 0, positive 3. Think about what you're looking at. We know we're going right and left 5, right? Up and down 3. What's the standard equation of a parabola look like? Or an ellipse look like? X squared over something plus y squared over something equals 1, right? Do I know how far right and left I'm going? It's 5, so what goes here? 25. Do I know how far up and down I'm going? Yes, 3, so this goes 9. You done. That is all you need. All the ones that they give you a covertex and a vertex are super, super easy. But now look at number 23. What do they give you? They give you vertices where? 0, 8. So 0 really plus and minus 8, right? And then they give you your foci. And those are at 0, 6, right? So 0 plus and minus 6. Think about what you're looking at. 0, 8 is up here and down here. So those are your vertices. And then 0, 6, those are your foci. Your ellipse has to look something like this, right? Okay, let's write our answer. We know it's got to be x squared over something plus y squared over something equals 1. Do I know how far my ellipse goes right and left? No. Do I know how far up and down? What's the answer here? 64, right? Because I went up and down 8. How am I going to find right and left? Also, why did I draw it elongated this way and not farther this way? They said that's a vertex, which means that has to be the bigger number, right? That's important because in order to find this number, I'm going to have to use my c squared equals a squared minus b squared equation. What's my c value here? The c is the distance to my foci, right? So that's 6. So this is 36. Now, the 64 goes somewhere. It's either the a squared or the b squared, and it matters. Which one is it? Is it the a squared or the b squared? And how do you know? How do you know it's the a squared? How do you know it's the bigger of the two numbers? The easiest way is they called it a vertex, right? It's also on the major axis. This is going to vary from question to question on those. So sometimes you'll know the b and not the a. How do you solve this? You would subtract, and the negatives are going to cancel. So what's 64 minus 36? That's 28. 8? Is that right? What's 64 minus 36?
Yeah,
Negative 28, and the negatives cancel. And there's your answer. Easy enough? When you do a question like 34, you're going to have the co-vertex and the focus point. Okay? When you put it in the c-squared equation, just make sure you put the known one in for b instead of a, because you know it's got to be the smaller number. Does that make sense? All right, so the first set of problems, 3 through 14, you draw the graph, or you put it in standard form, you draw the graph, label all the parts. Easy? 17 through 34, all you got to do is come up with the equation. Easy enough? If you turn the page, again, there's one section that I really, really like, 36 through 44. What's mixed in all there? You have parabolas, you have circles, and you have ellipses. How do you recognize a parabola? One variable will be squared. So which problem would be a parabola? What's the first parabola? 38. That's parabola. How do you recognize the difference between a circle and ellipse? Because they're both x squared plus y squared. Doesn't have to be fractions. Like, look at 37 and 40. One of those is a circle. One of those is an ellipse. Remember, this right here was a circle, wasn't it? What's significant about this ellipse? What makes this ellipse actually a circle? The numbers are the same. The coefficients are the same. If you draw an ellipse and you go the same distance right and left as you do up and down, you're not going to be drawing an ellipse. You're going to be drawing a circle, aren't you? So out of 37 and 40, which of those two is actually a circle? 40, because the 30s are the same. So that one I would actually divide by 30 to get the x squared plus y squared equals r squared. For number 37, I would divide by the 2025 to turn that into a 1. Does that make sense? So when they're the same, when the coefficients are the same, it's a circle. When they're different, it's an ellipse. Because you'll just go different distance up and down as you will right and left. Easy enough? All right, that's it.